All right, everybody, we are back despite some technical difficulties earlier. This is the follow-up to our class session number 2, and I wanted to just start by reviewing the perfectly competitive profit maximizing behavior of firms in our competitive market model. So to start, recall that the price in a market is determined by the supply and demand in that market. And we are making the assumption that a perfectly competitive firm, because they are a very small entity in the market, they're almost atomistic, like a granule of sand in a ever vast desert, that the firm is going to just look at the price in the market and take that price as given because it has zero market power, meaning at that flat demand curve from the firm's perspective, no matter if the firm produces a low level of output or a high level of output, the firm will not have any effect on the price because the price is being determined in the market in that left-hand diagram. Now, the behavior of the firm that is consistent with profit maximizing essentially involved us doing a marginal cost benefit analysis and thinking about our level of production. We argued that if the marginal revenue exceeded the marginal cost, and again, the marginal revenue is the benefit the seller gets from selling the next unit, then the seller would want to go ahead and increase his production level. However, if the marginal revenue of the last unit produced exceeded the marginal cost, that means the last unit we actually made a marginal loss on, and we could increase our profits by cutting back on production and lowering our level of output. So if we are actually maximizing profits, it has to be the case that we're producing at a level where the marginal cost and the marginal revenue of production are the same. And we can find that on the diagram here at this output level of Q star. Okay, note that if we follow Q star back up to the average cost curve, we can also compute the average cost per unit. So the vertical distance in the right diagram between the red line and the average cost per unit is the amount of profit per unit that the firm is making on average. If we multiply that distance by Q star, then we'd be calculating the area of this green rectangle, which is calculating the maximum profit that we could make when the price is at P star. Okay, now the plot sort of thickened here, if you remember from class, in that any firms out of the industry now notice that all of the firms in the industry are making this profit. They're reaping a positive piece of economic pie. Recall that all the firms in the perfectly competitive model are identical in terms of their technologies. So looking at this picture from the perspective of one firm is enough for us to infer that the case is also true for all of the firms. Now, once outsiders recognize that there is profit to be made in this industry, our prediction was that in the long run, when they're able to change their capital allocation and enter the market, that the number of suppliers in the market in the left-hand diagram would increase, shifting that supply curve to the right. Okay, note that the rightward shift of the supply curve puts downward pressure on that market price, which also then changes the demand curve from the firm's perspective in the right-hand diagram. So notice the price dropped a little bit. Okay, if we apply the same profit maximizing rule and find that output level or marginal revenue equals marginal cost, now we can observe that the firm is going to respond by actually producing less output, provided that it does not shut down. Okay, remember, in order for us to assess the shutdown condition in the short run, we would also need the average variable cost curve drawn. So let's assume for the moment that the average variable cost is much lower than the current market price. So the firm is not going to shut down, meaning it produces Q prime. And in doing so now, note that the average cost has not really changed. We went from the right side of the average cost curve to the left. So the average cost of Q prime and Q star is actually the same, but the price now is much lower, indicative that the firm now is making a loss at a price of P prime when it produces Q prime. Okay. And we can see that loss there because the price is lower than the average cost of production. The price is the average revenue, if you think about it that way, right? Every unit we sell, we get the same revenue back. However, the cost had stayed the same. It's higher, the revenue is lower, and our maximum profit now has turned into a loss. So Note that this loss here is the smallest loss we could guarantee ourselves. So that pink box, again, that defines the area of measuring our profit when we are doing the best that we can. So despite the fact the firm is making a loss, that does correspond to the best it can do, the maximum profit that it can make. All right, now our prediction, if we transition back to the long run, is that if firms now are making losses in the long run, then they're going to start to exit, and the supply curve in the left-hand diagram would then shift back to the left, putting upward pressure on the price and increasing the firm profits. We characterized a long-run equilibrium in class on Saturday, whereby no market agents had an incentive to change their behavior. And what we mean is no outsider firms had an incentive to enter, and no insider firms had an incentive to leave. And the situation that drove us to that equilibrium, so I want you to imagine the supply curve shifts to a location where there is no profit to be made and there is no loss to be made. Okay, that corresponds to the long-run equilibrium in this market. And when that happens, hey, the demand gets pushed to a level where marginal cost and average cost are equal to the price of the good in the long run. Okay, what this means is not only is the firm doing the best it can, but the best that it can corresponds to exactly zero profit. So the firm is also breaking even here. Note that the firm winds up minimizing average cost. It does produce at that minimum efficient scale of production we discussed in class. So just to kind of summarize here, okay, if a firm is maximizing profits, it's got to be producing at a level of output where marginal revenue equals marginal cost. And this is true for any firm in any market structure. If MR was greater than MC, then we can make a marginal profit by increasing production, and we can increase profit. If MR is less than MC, then we can increase profit by cutting back on units where we made marginal losses, again, pushing profit up. Okay, note that in the case of a competitive firm, when we didn't have any market power, the demand curve was completely flat from the firm's perspective. So even if it produced a little or a lot, it was not able to influence the market price. And because of that, the price and the marginal revenue in the case of a competitive firm wound up being the same. The demand curve and that marginal revenue curve were both right on top of each other. And this was a consequence of each unit being sold at a constant price. If the demand curve had sloped downwards, which it does when a firm has market power, which we'll look at in a minute, then the MR curve and the demand curve are not necessarily the same. And we'll have to be careful about that. Okay. Moreover, we saw that when firms were making a positive profit in the short run, this tended to incentivize entry as we transition to the long run. And this type of entry wound up increasing market supply, putting downward pressure on the equilibrium price, and reducing the profits to the firms. If firms are making negative profits, we saw that they may or may not shut down depending on which time horizon they're in. In the short run, the firm only shuts down if it's not able to cover its average variable cost, the cost of the ingredients going into each unit. However, in the long run, the shutdown condition was a little bit different. We only shut down if profits were negative. Recall in the long run, all the costs are variable, all inputs are variable. And in the case where firms were making negative profit in the long run, this induced firms to exit, incentivized them to exit, reducing market supply, increasing the equilibrium price, and putting upward pressure on firm profits. So that zero profit equilibrium that we discussed, this was a situation where no outsiders or insiders had incentives to change their behavior. They were content doing what they were doing because there was an incentive to go in or to leave the industry. Okay. In the long run equilibrium, we saw that there was a very nice property in that firms are very efficient in producing at the output level that minimizes the average production cost. This is efficient from a societal standpoint. And we argued that the minimum efficient scale of production in some sense can be thought of as determining the optimal size of a firm in the long run equilibrium from the perspective of the scale of production is defining the size of the firm here. Okay, so that long run equilibrium again is described by a situation where price equals marginal cost, the firm is maximizing profits, but price is also equal to the average cost of production. The firm is also breaking even. Okay, the next thing we did is we started thinking about how to model market power. So we started off in the case where we had absolutely no market power, which we modeled with a flat demand curve. And then we argued that if we just tilted that demand curve downwards, then we would be modeling a situation where we have some market power. And then we had this technical issue to deal with, that when we did tilt the demand curve downwards to model market power, so that now we were able to manipulate the price by changing the quantity along the horizontal axis, the marginal revenue curve actually swings down and becomes a little steeper than the demand curve. Specifically, in the case of a straight line demand curve, the marginal revenue curve will always be exactly twice as steep. So we discussed a little shortcut in class where if you have the demand curve equation, you could get the marginal revenue equation very easily in this case by just using the same intercept on the vertical axis and doubling the slope from the demand curve equation. Okay, so the demand curve swings down. Now we have market power, but the MR curve swings down even further. And again, our goal is the same. We wanted to look at the profit maximizing behavior of the firm, but now in a situation where the firm has some market power. We're going to jump to an extreme case here where not only are we a firm with market power, but we are the only firm with market power, which corresponds to a monopoly, meaning that the demand curve that I'm drawing in this diagram in this particular case isn't just some residual demand curve from the firm's perspective. That demand curve there is the actual market demand curve. Okay, so big difference here. The firm only sees that flat demand curve like the firm is looking at just the beach, can't see the whole ocean, but because the monopolist is a very large entity in the market, it's able to see the entire market. It can look at the whole ocean at once. It's a very big fish in the sea, and it's not just able to see the quote-unquote beach. So the monopoly does, in fact, observe the entire market demand curve, and the monopolist's goal is really the same as any firm's. It wants to maximize profit. So the logic that we use in thinking about this cost-benefit analysis of the margin that identifies the profit maximizing output, that hasn't changed. The firm is, if the firm is maximizing profit, then this is consistent with it, again, producing at a level of output where marginal revenue and marginal costs are the same. Note that the demand curve and the marginal revenue curve are not the same anymore, so that the price, which is measured along the demand curve, exceeds the marginal revenue at any positive level of output. So we are going to apply that first order condition here, that profit maximizing condition. Look at the output level where MR equals MC. So we would produce QM to maximize profits here. In order to figure out the price the monopolist is going to charge, we're going to go all the way up to the demand curve, which recall measures the maximum price we could extract from a consumer. And then we can look at the average cost of production if we were curious about measuring the amount of profit the monopoly made in that profit maximizing equilibrium. Okay. So one side note about the monopoly model, we have barriers to entry as an assumption, keeping other firms from entering. So we don't actually have to worry too much about the two time horizons, short run versus long run. If the monopolist is making a profit in the short run, then it will be able to keep that profit as we transition to the long run because no firms are able to enter the market. If the firm is making zero profit in the short run, then it will also make zero profit in the long run, again, because no entry is going to occur. So the long run and short run picture for the monopoly are more or less the same. And we don't have to really worry too much about any entry occurring because we've assumed away the mechanism by which entry can occur. We assume that there are barriers to entry keeping firms out. Now, what we would like to do next is make a little comparison of the monopoly outcome compared to the perfectly competitive outcome. So what I'm going to do is I'm going to draw on this same diagram what the market outcome would be if this firm was characterized as a competitive price taker, meaning the supply curve for the firm would be defined by the marginal cost curve in this picture. Okay, so let's do this. Let's go ahead and label now the competitive market allocation. So remember, the marginal cost curve will be the competitive firm supply curve. So if we assumed here that the monopolist, the technology that the monopolist has is the same as the technology that a competitive firm would have in this market, or rather that all of the competitive firms would have in this particular market, then the supply curve would be the marginal cost curve. Demand curve is still the demand curve. And the market equilibrium in perfect competition would be described by the usual allocation, P star, Q star. Okay. So recall again that if the market was competitive with the exact same technology as the monopolist in total across all the competitive firms, then the MC curve would be the supply curve. Okay. So the final P and Q associated with the competitive market outcome is easily identifiable, and we can recognize here the source of the market failure stemming from this concentration of market power around the monopolist. And that is that the quantity of trade has dropped relative to Q star. Okay, so we can identify that usual deadweight loss triangle here, and it's not really a triangle, it's close, because the MC curve is in a perfectly straight line. So we can identify here the efficiency property of the monopoly allocation, that the economic pie is absolutely shrinking, that the monopolist is preventing some mutually beneficial trades. Note that the consumers are worse off in the presence of a monopoly. Okay, the monopolist is able to extract this green chunk of the consumer surplus as a zero net transfer from the buyers to the seller. Okay, also note that this pink triangle is not captured by anybody because it's part of the societal deadweight loss. So the consumers are only left under the monopoly allocation with that tiny blue triangle in the top left corner. And we can summarize the full equity and efficiency implications looking at the full surplus picture here. That blue triangle in the top left is the consumer surplus under monopoly. Okay, the green wedge is the producer surplus. And that pink, somewhat triangular region is our deadweight loss. So again, because the monopolist is blocking mutually beneficial trades, the size of the total surplus pie is being reduced. Why would the monopolist do that? Well, the monopolist, again, doesn't care about the total size of the economic pie. The monopolist cares about is his cut of it. And the monopolist is absolutely able to increase his share of the economic pie. And this comes really at the expense of consumers and at the expense of the entire pie itself. All right, now, I wanted to just discuss an issue very quickly before we wrap this video up and start getting into the next sequence of videos related to measuring market power, price discrimination, and regulating monopolies. But you may be wondering to yourself, is there such thing as a pure monopoly in a product space to begin with? We argued that a competitive market probably doesn't exist in the way we've purely described a perfectly competitive industry. So that seemed a little unrealistic. We were using a very unrealistic model to conduct our supply and demand analysis. And the economist answer to this question, is there such thing as a pure monopoly in a product space, is probably a pretty typical economist answer, in that it depends really on how you define the product space or the relevant market. We often think of monopolies from the perspective of lack of consumer choice rather than a literal monopoly in a particular product space selling a completely unique product. For example, there are many broadband providers in the United States. So we wouldn't think of the broadband market as necessarily a pure product monopoly. However, if you look carefully at the choice that consumers have, consumers in certain regions only have one broadband provider that services their area. So from the perspective of the consumer's choice, there is only one seller that they have access to, and that seller faces no competition. Okay, we could also define a monopolist in some sense with respect to product differentiation. What I mean by this is that we can think of Coca-Cola as having a monopoly over Coke and Pepsi-Cola as having a monopoly over Pepsi, but neither is a pure monopolist if we were to sort of zoom out and generalize the definition of the product space to be the market for soft drinks in general, as opposed to the market for Pepsi or the market for Coke. Jumping back to the broadband picture, here is an interesting diagram from an article that you can find online that looks at the lack of competition in the broadband industry. And you'll notice in this picture, this is a map of Twin Cities and Minneapolis. And it shows us some coverage, broadband coverage from Comcast, Charter, And you'll notice if you look in that diagram, there is a little red region where consumers actually can choose from both. But in the areas where there's only orange or purple, consumers have choices between no other alternatives. They can choose only Comcast or only Charter, meaning effectively Comcast and Charter are operating monopolies with respect to the consumer choice in those purple and orange areas. Okay, I'm going to show you another picture that shows the consolidation that has been taking place in the banking industry over the past 10 to 20 years here. And you'll notice, looking at this, that we don't have a pure monopoly situation here, but it absolutely looks like we are approaching some sort of an oligopoly. And it may be prudent to think about to what degree are we able to measure the market power that a firm is wielding. And that is exactly the issue that we are going to start discussing in the next set of slides. So hopefully this was a good review of what we had talked about in the class session. There are some slides posted in the supplemental materials tab on Olay. So happy hunting, and I will see you shortly in the next video slide, or video segment rather.